guys. Today we're going to learn all the things about polynomials in standard form. Okay? So we know that the degree is the biggest exponent. All right, so what? Why is that important? Well, we're about to find out. Let's go. All right, so let's think about graphs and their exponents. Let's think about the functions and the exponents that they have, the degree, okay, the biggest exponent. All right, so if I have y equals x to the first plus 3, my degree is what? X. And just as a reminder, if you see x, it's the same thing as x to the first or 1x, or even 1x to the first. Okay, they're all the same thing. That 1 is there, but we just don't write it because we know that it's assumed. Okay, so my degree is 1. And this graph is called what? It's called a linear graph. Perfect. What about this one? My function is y equals x squared plus 3. What is my degree? Correct. It is 2. My biggest exponent is 2. What is this graph called? Does anybody remember? It does begin with a Q. It's one of those weird ones. It's quadratic. Beautiful. This is a quadratic graph. Okay. What about this one? My function is y equals x cubed plus 3. My degree is what? 3. And this graph, it is called cubic. Good job. All right. What about this one? Y equals x to the fourth plus 3. My degree is 4. What type of graph is this? It's another quadratic graph. What about this one? Y equals x to the fifth plus 3. My degree is 5, and this graph is still considered cubic. Okay. What about this? Y equals x to the 22nd plus 3. My degree is 22, and my graph is still quadratic. And this one, y equals x to the 23rd plus 3. My degree is 23, and my graph, it's another cubic. So this picture has all of the functions layered on each other. And I grouped them the same, and I wanted to see, what do you guys notice and what do you wonder about the functions and their graphs? There's a reason why I grouped them the way that I did. Yeah. So if my degree is even, if that biggest exponent is even, I make a quadratic graph. If it's odd, I make a cubic. Okay. So if it's even, and what I want you guys to know is if it's even, my degree is even, both arms will go the same direction. If it's odd, they go in opposite directions. Okay. Now if you look at my arms, they go the same direction. So if it's even, they could go up or down. But if they're odd, then both arms are going to go in opposite directions, whether one is up, the other one is down, or the other one is up and the other one is down. So what would these graphs look like? If I have 3x to the 67th minus 4. You see what I did there? 6, 7. Yeah. So if it's 6, 7, is that odd or even? It's odd. So are my arms going to go, if it's even, they're going to go in the same. If it's odd, odd opposite. Odd opposite. So are they going to go in the opposite direction or the same direction? Since it's odd, they're going to go in the opposite direction. So it could look like this, or it could look like Okay, what about 3x to the 4th minus 4? Is my degree even or is it odd? It's even. So that means that they are going to go, is it the same or the opposite? Correct, it's the same. So we could go like this or like this. What about x squared plus 6? Squared is even, so again, the same direction. And then I want you guys to take a second and work with your group for 4x to the 5th plus 6. Talk it out. Is it odd or is it even? And do they go in the opposite or the same? Correct. It is odd, and so they're opposite. Beautiful. All right, let's keep going. So, how would the values in the graph change if the leading coefficient was a negative? What do you guys think? You think they would flip-flop? That's good. You think one would be up and one would be down? That's good too. You think they would crisscross? That's cool. I love these. All right, let's keep going. Let's see, shall we? So I plotted y equals x squared plus 1 is red, and y equals negative x squared plus 1 in purple. What do we notice? Oh, they're flip-flopped. Right. So red is literally, well, purple is literally red upside down. That's good. That's good. All right. What about these? All right. So we have y equals x squared plus 1 in red and y equals negative x squared plus 1 in purple. All right. So as the x values get further and further away from 0, the y values get more positive and positive. And for purple, as the x values get further and further away from 0, the y values get negative. Okay? All right. What about these? What do we notice and what do we wonder? We have y equals x cubed plus 1 in red and y equals negative x cubed plus 1 in purple. They are flipped. And actually, I think it's really cool when you put them together. They look like what? They do look like DNA, don't they? They're really, really cool. I love that, yeah. All right, let's keep going. So with y equals x cubed plus 1, as the x values get more negative, my y values also get more negative. But as my y values get more positive, my y values also get more positive. And for y equals negative x cubed plus 1, as the x values get more negative, my y values get more positive. And as my x values get more positive, my y values get more negative. All right. So if the leading coefficient is positive, then it's the normal way, and that's how I'll say it. But if they're negative, it's opposite. And so the best way that I like to think of this is as a grid. Okay. So we're going to combine all that we've learned. And again, our objective is I can find the end behavior of a function from its standard form. And we're going to combine that degree and that leading coefficient to talk about end behavior. So the end behavior is how the outputs of a function change as we look at the inputs further and further from 0. So basically, how do the y values react to the different x values, if they're positive or negative? What happens? And this is determined by the degree and the leading coefficient. All right, so this is the table that we're going to use to combine everything. If it's odd and positive, then if it has an odd degree and a positive leading coefficient, then you'll see that it does this kind of thing. And I like to think of it as Mario. So if you think of Mario, pop in the mystery box, then this is Mario. And if it's a odd degree but a negative leading coefficient, then it's evil, quote unquote. So it's Wario. And then if it's an even degree and a positive leading coefficient, to me this looks like a big old smiley face. And if it's an even degree and a negative coefficient, then this is a frown or a sad face. Okay. And so now you guys are going to take the time and write these in your notebook. You're going to write the table and a couple more definitions that I am putting up in a second.